You've probably seen the picture. It's everywhere. It's on t-shirts, in museums, in textbooks. It's an ape-like creature hunched over, knuckles dragging. Then it slowly stands up. The next one is a little taller, a bit less hairy. The one after that looks more like a caveman. Finally, you get a modern human standing tall, holding a briefcase or a smartphone. It's called the March of Progress. It's a simple, powerful image. It tells a clean story. We started as apes, and we got better and better and better until we became us. A straight line, a ladder. Each step an improvement on the last. It feels right. It feels like destiny, but it's completely wrong. The story of human evolution is not a straight line. It's not a ladder. It's not a neat progression from dumb to smart, from primitive to advanced. If you want a better picture, think of a bush, a big, messy, sprawling bush with lots of branches. Some branches grow long and lead to other branches. Some branches are short and just stop. Some branches twist around and even touch each other. And we, Homo sapiens, are just one twig on one of the surviving branches of that bush. For a very long time, we were not alone. We shared this planet with other kinds of humans. To understand why the line is a myth, we have to talk about how evolution actually works. It doesn't have a goal. There is no plan. Evolution is just a process. It's about how life adapts to its environment. It's driven by a few simple facts. First, there's variation. In any group of living things, no two individuals are exactly alike. Think about people you know. Some are tall, some are short, some have good eyesight, some don't. There are endless small differences. This is true for every species. Second, these variations are passed down. Tall parents are more likely to have tall children. Genes carry these traits from one generation to the next. Third, life is a struggle. Resources are limited. There's not enough food or shelter for everyone. And some individuals have traits that give them a tiny edge in their specific environment. Maybe they're a little better at finding food, maybe they're slightly better at escaping predators, and maybe their bodies are better at handling the cold. The ones with the helpful traits are more likely to survive and have kids. And their kids will inherit those same helpful traits. The ones without the edge are less likely to survive and have kids. Over a long, long time, we're talking millions of years, the helpful traits become more common in the group. The group as a whole changes. It becomes better adapted to its surroundings. That's natural selection. The environment is the key. A trait that's great in one place might be useless or even harmful in another. A thick coat of fur is a lifesaver in the Arctic, but it's a death sentence in the desert. There is no such thing as better in a universal sense. There is only better adapted to this specific time and place. So where does the messy bush come from? It comes from populations getting separated. Imagine a group of animals living in a forest. A big river forms and cuts the forest in two. The animals on one side can no longer breed with the animals on the other side. They are now two separate populations. The environment on the east side of the river might be a little different from the west side. Maybe it's wetter or the main food source is different. Over thousands of generations, the two groups adapt to their own local conditions. They start to change in different ways. Their branches on the evolutionary bush are now growing in different directions. If they stay separated long enough, they might become so different that they can't breed with each other anymore, even if the river dries up. Now you have two distinct species where there used to be one. This is how the bush grows new branches. Human evolution followed this exact pattern. It wasn't one species turning into the next in a single global line. It was about different groups of our ancient relatives spreading out, getting isolated, and adapting to new environments in Africa and beyond. The result was a world filled with many different types of human-like creatures or hominins. Let's go back in time. Maybe 6 or 7 million years ago in Africa, there was a species of ape. We don't know exactly what it looked like, but it was the common ancestor of both modern humans and modern chimpanzees. Its population got split. One group stayed in the dense forests and evolved into the chimps and bonobos we see today. Another group ended up in a different environment, perhaps a more open woodland or savanna. This group faced different challenges, and it started down a different path. One of the first major changes was walking on two legs. We call this bipedalism. For a long time, people thought our ancestors stood up so they could have big brains. The March of Progress picture supports this. The brain gets bigger as the posture gets straighter. But the fossil evidence tells a different story. One of our most famous ancestors is Lucy. She was discovered in Ethiopia in 1974. Lucy was a member of a species called Australopithecus afarensis. She lived over 3 million years ago, and she was a perfect example of how evolution is not a straight line. Lucy's skeleton shows she had a brain about the size of a chimpanzee's. It was tiny. But her leg bones, her pelvis, and her feet clearly show that she walked upright. This was a huge discovery. It proved that walking on two legs came long before big brains. Our ancestors were walking around on the African savanna for millions of years with small ape-sized brains. Why did they stand up? We don't know for sure. Maybe it helped them see over tall grass. Maybe it freed up their hands to carry food or tools. Maybe it was a more energy-efficient way to travel long distances. Whatever the reason, it was the first major step that set our lineage apart from the other apes. But the Australopithecines, Lucy's kind, were not just a single link in a chain. They were a whole group of species. There was Australopithecus africanus, Australopithecus sediba, and others. There were also other related groups, like the genus Paranthropus. These were hominins with huge jaws and massive chewing muscles, likely adapted for eating tough, fibrous plants. They were a successful branch of the hominin bush that thrived for over 1 million years before eventually dying out. They weren't our ancestors, they were our ancient cousins. They were a different experiment in how to be a hominin. Around 2.5 million years ago, something new appeared, the first members of our own genus Homo. The first one we know of is called Homo habilis, which means handyman. They were given this name because they were found with simple stone tools. They were a bit smarter than the Australopithecines with slightly larger brains. But they still weren't much taller than Lucy. Was Homo habilis our direct ancestor? Maybe. Or maybe they were another side branch. The fossil record from this period is patchy. It's like having a book with most of the pages ripped out. We have a few sentences here and there, and we try to piece together the story. We can see that several different kinds of hominins, including late Australopithecines, Paranthropus, and early Homo, were all living in Africa at the same time. It was a crowded world. They were likely competing for resources. It was not a simple linear progression. It was a messy reality of different species trying to make a living. Then came a real game changer. A species called Homo erectus. These guys were different. They were bigger. They were built more like us, with long legs and shorter arms. Their brains were significantly larger than anything that came before. Homo erectus was incredibly successful. They were probably the first hominins to control fire. They made more sophisticated tools, and they were the first to leave Africa. Around 2 million years ago, groups of Homo erectus started to spread out. They walked into the Middle East, across Asia, and into Europe. This was a massive event. It was the first time our lineage became a global, or at least an old world, phenomenon. Because they spread out over such a huge area, the different populations of Homo erectus started to become isolated from each other. The group that went to Indonesia faced different challenges than the group that went to Spain. And so the bush of human evolution grew even more branches, okay? In Europe, Homo erectus populations eventually evolved into new species like Homo heidelbergensis, and then later into one of our most famous relatives, the Neanderthals. Neanderthals, or Homo neanderthalensis, get a bad rap. The word Neanderthal is used as an insult for someone brutish and stupid. This idea comes directly from the March of Progress thinking. They came before us, so they must have been a dumber, uglier version of us. But, again, this is a myth. Neanderthals were not stupid. Their brains were, on average, slightly larger than ours today. They were incredibly well adapted to the cold, harsh environment of Ice Age Europe. They were stout and powerfully built, which helped them conserve heat. They were expert hunters, taking down large animals like mammoths and woolly rhinos. They made complex tools, they controlled fire, and they had culture. We have found evidence that Neanderthals buried their dead. They used pigments, maybe for body paint. They made simple jewelry from eagle talons and shells. They were not grunting cavemen. They were a different kind of human with their own long and successful history. They thrived in Europe and Asia for hundreds of thousands of years, far longer than our own species, Homo sapiens, has been around so far. While the Neanderthals were evolving in Europe, other things were happening elsewhere. In Asia, populations descended from Homo erectus continued on their own path. And recently, scientists discovered a whole new branch of the human family tree from a single finger bone and a few teeth found in a cave in Siberia. By analyzing the ancient DNA from these fragments, they found a population that was genetically distinct from both Neanderthals and modern humans. They called them the Denisovans after the cave where they were found. We know almost nothing about what they looked like. But we know they were there. They were another one of the many human types sharing the planet. And there were even weirder relatives. On the Indonesian island of Flores, archaeologists found the skeletons of a tiny species of human barely 3 feet tall. They were nicknamed hobbits. This species, Homo floresiensis, had tiny brains but still made stone tools and hunted. They probably evolved from a population of Homo erectus that became stranded on the island and, over thousands of years, evolved to be smaller, a common phenomenon in island environments called island dwarfism. They were still alive as recently as 50,000 years ago. In a cave in South Africa, another recent discovery unveiled Homo naledi, a species with a strange mix of ancient and modern features. It had a small brain like an Australopithecine, but hands and feet that look very much like ours. The cave was incredibly difficult to get to, suggesting they may have been deliberately placing their dead there, a surprisingly complex behavior. So let's paint a picture of the world, say, 100,000 years ago. It's not a world with one human species progressing towards modernity. It's a world that looks more like a J.R.R. Tolkien fantasy. In Africa, our own species, Homo sapiens, had recently evolved and was starting to look and act like we do. In Europe and the Middle East, the Neanderthals were the dominant human form. In Asia, there were the Denisovans and probably remnant populations of Homo erectus. And on the island of Flores, there were the hobbits. There were at least 4, maybe 5 or more different kinds of humans living on Earth at the same time. The straight line is not just wrong, it's impossible. The reality was a human world with a diversity we can barely imagine today. So where do we fit into this picture? Our species, Homo sapiens, evolved in Africa. The oldest fossils that look like us are about 300,000 years old. For a long time, we were just one of those African hominin groups. We weren't special, we weren't destined for greatness, we were just another twig on the bush. But something did happen. Around 70,000 to 100,000 years ago, our African ancestors started to behave in new ways. We see a sudden explosion of creativity and innovation. They started making much more complex tools, creating art, beads, and personal ornaments. This suggests a change in how their brains were wired. Maybe they developed more complex language. Maybe they developed the ability for symbolic thought to think about things that aren't right in front of them, like the past, the future, or the spirit world. This is often called the cognitive revolution. Armed with these new mental tools, groups of Homo sapiens started to expand out of Africa. This wasn't the first time a hominin had left Africa. Homo erectus had done it over 1 million years earlier. But this time was different. Wherever Homo sapiens went, they seemed to thrive and expand. And as they expanded, they met their cousins. They met the Neanderthals in Europe and the Middle East. They met the Denisovans in Asia. What happened when they met? This is one of the biggest questions in human evolution. For a long time, scientists thought our ancestors simply replaced the other humans. Maybe we were better hunters or had better technology and we just outcompeted them for food and territory. Maybe we were more violent and killed them off. This replacement model fits nicely with the old March of Progress idea. We were the superior model and we replaced the obsolete ones. But again, the truth is messier and far more interesting. And the proof is inside you. It's in your DNA. When scientists learned how to extract and read the ancient DNA from Neanderthal and Denisovan bones, they made a shocking discovery. They compared it to the DNA of people living today, and they found a match. If your ancestry is from outside of Africa, you have about 1 to 2% Neanderthal DNA in your genome. If you have ancestry from parts of Asia or Oceania, you may have up to 5% Denisovan DNA. What does this mean? It means our ancestors didn't just replace the other humans. They had children with them. There was a time in Europe and Asia when Homo sapiens and Neanderthals were meeting, interacting, and interbreeding. The same thing happened with Denisovans. We are not a pure species that wiped everyone else out. We are a hybrid. We carry the genetic ghosts of these other human worlds within us. This is the ultimate proof that human evolution was not a line, it was a network. The branches of the bush didn't just grow apart, sometimes they grew back together and exchanged genetic information. The story of our origins is a story of encounters, of mingling, of a shared human heritage that is far more complex than a simple ladder of progress. So why did the others disappear? Why are we the only humans left? We don't know for sure. It probably wasn't one single event. The Neanderthals, for example, were already in decline before we showed up in large numbers in Europe. The climate was changing rapidly, and their populations were small and fragmented. Our arrival might have just been the final push. Maybe our slightly more advanced technology, our larger social networks, or our greater adaptability gave us a competitive edge. We seem to be a species that is very good at adapting to almost any environment on Earth, from the Arctic to the rainforest. Perhaps the other humans were more specialized, better adapted to a specific environment that was now disappearing. Maybe we brought new diseases with us from Africa that their immune systems couldn't handle. Or maybe we just had more babies. A very small advantage in birth rate, compounded over thousands of years, can allow one population to completely overwhelm another without any need for violence. The answer is likely a combination of all these factors. By about 40,000 years ago, the Neanderthals were gone. The Denisovans disappeared around the same time. The little hobbits on Flores held out for a bit longer, but they too eventually vanished. And for the first time in millions of years, there was only one species of human on planet Earth. It's us. Our current solitude is a very recent and unusual state of affairs in the grand history of our family. The myth of the straight line is so hard to shake, because it's a comforting story. It tells us that we are the pinnacle of creation, the inevitable result of millions of years of progress. It places us at the top of a pyramid, but the scientific evidence tells a different, more humble, and more fascinating story. We are not the goal of evolution. We are an accident. We are the result of thousands of contingent events, of climate shifts, of geographic separations, of lucky genetic mutations. If you could rewind the tape of life and play it again, the chances of something like a human evolving are incredibly small. Thinking of our history as a messy bush changes how we see ourselves. We are not the peak of a ladder, but one surviving twig on a vast and ancient tree of life. Our cousins, the Neanderthals and the Denisovans, were not failed experiments or evolutionary dead ends. They were other equally valid ways of being human. They had their own long histories, their own successes. And part of them lives on in us. Our story is not a simple march forward. It's a sprawling family saga, full of lost relatives and surprising connections. We are the last survivors of a once diverse and vibrant human world, and understanding that messy, branching history is the key to understanding who we truly are. It replaces a simple, arrogant myth with a complex, humbling, and beautiful truth.